All right, let's perform and interpret hypothesis testing for a proportion of one population using RGuroo. So we have our problem, and in RGuroo, we are going to analytics, analysis, proportion inference, and one population. Problem says, a candidate in an election lost by 5.8% of the vote. The candidate sued the state and said that more than 5.8% of the ballots were defective and not counted by the voting machine. So a full recount would need to be done. His opponent wanted to ask for the case to be dismissed. So she had a government official from the state randomly select 500 ballots and count how many were defective. The official found 21 defective ballots. We're going to use RGuroo to test if the candidate's claim is true and less than 5.8% of the ballots were defective. We are going to identify the p-value. So we're here. We don't have a data set. We want is like summaries from our data. We're working with proportions, so we always need what is the sample size and what is the number of successes. Successes, when we talk about inference, proportions, we just talk about how many observations we were able to see in our data from what we were trying to find. So in this case, we had a total of 500 ballots, and then we were counting defective. So every time we found a defective ballot, that's a success for us because that is what we are interested in. So we had a 21 total defective ballots out of 500. So then now our proportion is going to be 0.042. All right. So that is the proportion of defective ballots in my sample. We are going to conduct a hypothesis testing. I'm going to leave the significance level as 0.05 because we don't have information here for that. The alternative hypothesis. So here it says to use the technology to test if the candidate's claim is true and less than 5.8 of the ballots were defective. So then less than means that we're going to do less than 5.8%. We always need to change the percentages to decimals because we're talking about proportions. So 5.8% to a decimal is 0.058. We are going to use a large sample Z for our proportions. It's the same we do for the confidence intervals. And so once we have that, if we click on the blue eye, it's going to ask us to label the factors. So I always say, you don't need to be very creative here. Just put letters on it because that's kind of what you want to move forward. At the end, what you want to pay attention to is your table. You have your test statistic right here, and you have your p-value right here. If we go back and we choose to do the confidence interval, then you will have your confidence interval, the lower and the upper, for the proportion of defective ballots in there as well. So p-value is 0.06293. So then here it's asking me for 3 decimal places. So if we go here, 0.062 followed by a 9. So then I need to change this to with a 3. So 0.063 will be the p-value for this case. All right, this is how we calculate the p, how we calculate the test statistic by hand. You don't need to know how to do that for now. So let's work on problem number 2. Steve listens to his favorite streaming music service when he works out. He wonders whether the service algorithm does a good job of finding random songs that he will like more often than not. To test this, he listened to 50 songs chosen by the service at random and find that he likes 32 of them. We're going to use Excel. No, Excel. We're going to use RGuroo to test whether Steve will like a randomly selected song more often than not, and then draw a conclusion in the context of the problem. So then again, I'm going to go back to RGuroo, and I am going to open another proportion inference for one population. Total sample size is 32. The ones that he likes were 32. So he has a 0.64 proportion. For success, the alternative is going to be greater than 0.5. And the reason for that is because the options that he has is he either likes the song or he doesn't like the song. So it's going to be a 50-50 chance. So he either, it's 50% he will like the song and 50% he won't like the song. So it says that Steve, that he will like a randomly selected song more often than not. So this is more than 50 he will like, less than 50 he won't like. So then we want to see like a greater than 50%. We do a large sample Z and we click in here. Again, we have an issue. So remember to just put a label for everything. And then we click in the I. And so we look at the p-value. The p-value is 0.023. That's the p-value. 0.023, it's smaller than 0.05. And when we have a p-value that is smaller than the alpha, we have evidence to reject the null hypothesis. So we reject the null hypothesis because we have sufficient evidence to conclude that Steve will like a random selected song more often than not. So we click that and we move on. Third problem, here we need to choose our hypothesis. So an economist wondered if people who go grocery shopping on weekends go more or less often on Fridays than any other day. She figured that if it were truly random, 20% of these shoppers will go grocery shopping on Fridays. She randomly sampled 75 customers who go grocery shopping on weekdays and asked them on which day they shop most frequently. Of those sampled, 24 indicated that they shop on Fridays more often than other days. The economist conducts a one proportion hypothesis test at the 1% significance level to test whether the true proportion of weekday grocery shoppers who go most frequently on Fridays is different than 20%. So here is your alternative hypothesis. So then our null hypothesis is that the proportion is equal to 20%. And then the alternative hypothesis will be that the proportion is different than 20%. And that takes me all the way down here to the last one. Null hypothesis, proportion is 0.2. Alternative hypothesis, proportion is different than 0.2. So we're doing a two-tail test. So once we have A, now we go B. We're going to go to RGuroo to perform the hypothesis test. So we go back here. He randomly, she sampled 75 shoppers. For those, 24 goes on Friday. So our proportion is 0.32. Alternative, as we chose it, the proportion is different than 0.20. This is a large sample Z. And then again, we label the factor, the success, and the frequency. And we click in here. So once we have that, the standardized observation stat, it's your test statistic. So the test statistic is 2. So we need 3 decimal places. So that would be 2.598. 2.598. And the p-value is this in here, again, 3 decimal places. That is 0.009. All right, again, this 2.59808 is your test statistic, and this 0.0093747 is your p-value. We got that correct, and then we use that to make our conclusion. So if we go back here, the hypothesis test is at a 1% significance level. So let me go back here. And let me, significance is 0.01. All right, and I change it because it tells me here if it is significant or not. If it is significant, it means that the p-value it's smaller than the alpha and we reject the null hypothesis. So we go here, again, 0.009 is less than 0.01. So we have the evidence to reject the null hypothesis, which means that at the 1% significance level, the data, our sample, provides sufficient evidence to conclude that the true proportion is different than 0.20, which is our alternative. All right, and with that, we are done here. And so again, I hope the video is helpful, helps you understand how do we conduct a hypothesis testing for a proportion, and that you can complete your homework.